This is Mr. Martin. These are video notes for Geometry Advanced. This is lesson 7.1. We're going to be talking about transformations and symmetry. So when discussing transformations in geometry, we're moving all the points of a geometric figure according to certain rules. And there's lots of different ways that we can move them around. So when we do this movement, we produce an image of the original figure. So anytime we talk about the image, we're talking about the new figure. So keep that in mind as we go through the notes and we go through the chapter and actually the rest of the school year. The image is referring to the new figure. So this process is called a transformation. And if the image is exactly the same size and shape, our fancy geometric word for this would be congruent. If it's congruent, that's our equality for geometry, as the original figure, then the transformation is called a rigid transformation or isometry. So make sure you know these vocabulary words: rigid, transformation, or isometry. And all of what we're going to deal with in this lesson, they're going to be isometries. So if the image, again, image is the new figure, is not congruent to the original one, then it's called a non-rigid transformation. For example, if the shape is reduced or enlarged, if it shrinks or gets bigger, it's a non-rigid transformation. So let's take a look at three types of rigid transformations. The first one is a translation, and it may be a little hard to see on your copies, but you notice that this point here is point T, and this point here is a T with a little apostrophe by it. We say in math T prime, and this is a very common notation in mathematics to use those little apostrophes. Sometimes you'll use two apostrophes. It's also used in calculus. But what it denotes is that T prime is a child of T. So it's basically coming from T. So we want to use the same letters to show that it was originally T and now it's T prime. Alright, and then over here we have R prime and over here we have I prime. So you can see that we've taken this figure in the top left and really we've just moved it over to here. So you notice this arrow that I use to show the movement, and really I can take this arrow and it would be the same arrow, same size, same direction to go from I to I prime or from R to R prime. So this is what we call a translation vector, okay, and it describes the translation of the figure to the image. Okay, so that's translation vector. That's some more vocabulary for you. So that's our first type of transformation. It's a translation. Our next type of transformation is a rotation. So again, it's kind of hard to see here, but we have triangle ABC, and the image over here is A prime, B prime, C prime. And you can see these little circles here. If I connect, so here's my point that we're rotating around. This is our center of rotation. So this is the center of rotation right there. And basically, if I connect the triangle to point A, and then I rotate this around point A until I get to A prime, this triangle would end up exactly where the top left triangle is. So we've got the center of rotation. In this case, the center of rotation is not on or in the original figure. It's outside of it. We'll talk about some stuff where the center of rotation is actually on the figure. So center of rotation is that red point right there, and then the angle of rotation, it looks like it's probably pretty close to 90 degrees, so the angle of rotation right here. So for this example, angle is about we're just estimating here, 90 degrees of rotation. Alright, so that's our second type of transformation. It's called a rotation. The next is a reflection, and just like you would think it would mean, it's really just a mirror image. So I've got this black segment that separates these two figures. Again, over here I have triangle SUT, and over here I have triangle S prime U prime T prime. So if you put a mirror here on this black segment and you looked into the mirror, what you would see is this other triangle on the right. Okay, so the line of reflection, this is really the mirror. Okay, and again, sometimes the line will be not touching the original figure. Sometimes it could go right through the figure, and we'll deal with both types of cases. All right, so we're going to look at a little investigation, but you're going to need to get your Chromebooks set up for this. So what we want to do is open up, just kind of follow along for a second, and you're going to go to Google, and up here, I'm not sure where it's going to be on yours, but there should be some sort of apps. So you're going to click on that, and then somewhere you're going to have a web store. So on my screen, it's actually off the screen. It's on the bottom of the screen over here, but you want to click that little web store button. And over here, what you want to search for, let's get my, is GeoGebra. So it's GeoGebra, GeoGebra. Alright, so let's get rid of that. So you can see there's two different GeoGebra apps here. We don't want to use the beta, we'll just use the regular one. So I already have it installed here, and that's why it's telling me to rate it, but yours is probably going to say free, so go ahead and click on that and get it going. I'm just going to click on mine. Actually, so once you get that going, it should come up, and then what you want to do is you want to go back to your apps. For mine, it's in this upper left corner. I'm not sure where it will be for yours. And you should have a new app here, GeoGebra. So if you go ahead and click on that, and it'll just take a moment to load. And then we'll use this quite a bit throughout the school year, but for now, just kind of follow along. If you need to pause and rewind, feel free to do that. So hit the little graphics button and then click this button here to get rid of the axes. And over here is the algebra. We could leave that. We don't really need that. So again, you may need to pause as we go along. So go ahead and click this little polygon tool here. If you click the little triangle, it gives you a drop down, and we want just the polygon at the top, so polygon. And then just draw yourself a polygon. So just click a bunch of times. I'm going to just do a pentagon. Make sure you touch back to the original. Alright, so here's our polygon. And then what I'm going to do is I'm going to come over here, and I want a line. So I'm going to make a line. And I'm just going to draw it somewhere like this. Alright. And again, if you need to pause and rewind, feel free. Then I'm going to come over to here, and I want reflect about a line. So we're going to do a reflection. Reflect about a line. So if you go back up here, you can see that reflect about a line, it tells you what to do under that. It says select object to reflect, then line of reflection. So I'm going to click on that polygon. Let's see if I got it. And then I'm going to click on this line. There we go. And you can see it flips it over, and it actually gives it the prime notation. So here was A, B, C, D, E. Here's A prime, B prime, C prime, D prime, E prime. So here is my mirror. And if I grab my move tool over here, and I move one of my points here, you can see that no matter where I move my line, I still get a mirror image. So remember, this line that goes in between the two figures is like my mirror, and if I was going to look into the mirror, I would see the figure that's on the right side here. Okay, so now what we want to do is come back over to here, and I want to select the segment tool, and I'm going to come over here and I'm going to change this to my dashed line. You can pick whichever one you want. And then what I'm going to do is I'm going to connect each original letter with its child. So I'm going to connect A with A prime, and I'm going to connect B with B prime, and C with C prime. I'm going to move my mirror so I can see that a little more clearly. D to D prime, and E to E prime. Again, I know I'm going a little fast, so feel free to pause and rewind as needed. So click my move tool, move my mirror a little bit so I can see all of my different lines. So what we're looking at here is a figure with its image, and then we've connected each, and we've got my mirror going down the middle. So let's go back to our notes here. So I want you to draw a sketch of your final figure from the investigation. So mine, I'm just going to do a quick sketch here. It was something like this, and then I had my mirror, and then it was something like this. I'm just going quick, and then I had all these connected. Missing some. There's one over here. 1, 2, 3, 4. Okay, so here's my quick sketch. So from this little investigation, we come up with the reflection line conjecture. Okay, a conjecture is just an educated guess about something, and we're going to do this a lot in the class. And what I want you to do is try and figure out, if you have to go back to GeoGebra and try and figure things out. There's also some measure tools that you can work on and try and figure that out. So the line of reflection is the blank of every segment joining a point in the original figure with its corresponding point in the image. So work on that, see what you come up with. We'll talk about that when you come back to class and see what you get. Alright, so moving on to symmetry, a little bit more symmetry. We've got reflection symmetry. So we're going to talk about this with respect to individual figures. So if a figure can be reflected over a line in such a way that the resulting image coincides with the original, then the figure has reflection symmetry. So we want to figure out how many lines of symmetry do you think each figure has. And I'm going to do one of these for you and then let you go on and do the rest. So for this square, we're going to assume it's a square. Here's two different lines. So this line, I can fold it over on itself and it would exactly match up. So that indicates it has reflection symmetry. Or this horizontal line, I could fold it top to bottom. Or I could actually fold it along the diagonals. So we could say that this has four-fold reflection symmetry. Alright, so go ahead and pause the video and go ahead and work out some of these other ones. See what you come up with. We'll talk about that in class. And moving down here to rotational symmetry. If a figure can be rotated about a point so that its rotated image coincides with the original figure before turning 360 degrees, that's important, then the figure has rotational symmetry. So determine the type of rotational symmetry for each. So let's just take a look at the first one. So if I look at this point here, I can take the figure and rotate it to here, and it will land back up on itself, or to here, and then I can rotate it to here back to itself. So this one has three-fold rotational symmetry, or what we can say is it has 120-degree rotational symmetry. Alright, I'm going to go ahead and end this video now because we have trouble on YouTube if it's more than 15 minutes, and then there'll be just a short video to follow up.